What is up YouTube? Welcome back to another episode on Code with Ani. And in this video, we're going to take a detailed look at the algorithm behind garbage collection. In my previous video, I did mention about the concept of garbage collection in Java and how it is done. And in this video, I'm going to show you the exact algorithm that works behind the scenes for performing this garbage collection. This is quite an important concept, so do please focus on this video. And the algorithm that we're going to talk about is mark and sweep algorithm. Okay, so what is mark and sweep? It's as the name suggests, right? It's a two-step process. Okay, but before I even tell you how this looks like, I'll show you how the objects are linked in memory behind the scenes. Okay, so every object that you create initially, right, is called as a root object, meaning that's the starting point from where all other objects are linked. Okay, that's called as a root object. Okay, from the root object, you have other objects like object 1 and object 2. From object 1, again you are calling something else, right? So if you are able to call another method from object 1, then you will have another invocation there, another linkage there basically. So you have object 3 and object 4. And object 2 will be calling object 5 and object 6, for example. Okay, and all of these are linked like this. Let me try to put a slash between them. So it's coming here. Okay, same way here also you have a linkage. I'm just saying that root is connected to object 1, root is connected to object 2. Now object 1 is connected to object 3. Okay, and object 2 is connected to object 5, let's say. Okay, now as soon as an object is created in memory behind the scenes, right, this is how the heap data structure is organized. As soon as the object is created, it is marked with a value 0, okay, or false. Okay, and likewise all the objects are marked as false. Okay, false in the sense this is just a flag to indicate whether the object is reachable or not. Okay, when you're traversing through this heap. Okay, all of these are marked as false. As soon as they're created, there is a flag associated with the object which is marked as false. So this is how the heap is linked. Now what will happen is all the objects that are calling each other, like root is calling object 1, object 1 is invoking object 3, and root is calling object 2, object 2 is invoking object 4, okay, and object 5. Okay, so so object 3 and object 4 are this is the layering basically. So this is one row of layer, this is one row of layer, and object 1 is calling 3 and 2 is calling 5, for instance. Okay, now what will happen is during the mark phase, we will try to see which object is reachable from one another. So for example, root is able to reach object 1, right? So it will automatically say that, okay, root is true because root is able to connect to one more object, right? And this will also be marked true. Object 1 is able to reach object 3, so object 3 will also be marked true. Likewise, object 2 is able to connect to object 5, so both of these will be marked true. Okay, now once this mark phase is completed, you can see that this is how the data structure will look like. So root and all those other objects which are reachable are marked as true, which means these are all connected to each other. Okay, which means the invocations, that is one calling the other, right, that is always existing between these two, or all of these basically. Root calls 1, 1 calls 3, root calls 2, 2 calls 5. So this particular all these set of objects are continuously in use or in memory. So this is left as it is. Now during the sweep phase, what will happen is it will check, okay, what is marked as false here. Okay, object 4 is false, object 6 is false. This means that these two objects are not at all invoked by anybody. They were created, but they are just lying useless without being used. So these are the objects that the algorithm will target in the sweep phase, and it will remove these values. Okay, this is linked to 5, right? Yeah. So after this is removed, that is the 4 and object 6 are removed, right? The sweep phase completes, and again, as soon as it is completed, all of these will be marked as false again. Why it is marked false? Because again the mark algorithm will be triggered after some time, and it will again try to see the linkage between all the objects, whether it is accessible or not. And the way this particular algorithm iterates and identifies, right, it is called as a depth first search algorithm, and I'll talk about this in detail in the data structures and algorithms video, so stay tuned for that. But in short, it will identify what are all the objects that are linked to each other, and it will simply mark them as true. Now let's say tomorrow we stop invoking the object phi, let's say, and object phi is simply lying redundant and this connection is gone, right? Oh, sorry, this particular connection is removed. So mark face will again mark this true, this will be marked true, this will be marked true, this will be marked true. That's it. And sweep will go ahead and identify that object phi is no longer used, and it will remove it from memory. So I hope this clarifies how the mark and sweep algorithm works. I was able to draw a very rough figure here, so please bear with me on this one. I apologize if this is a little bit confusing to see, but I hope this is the algorithm working is very clear. It's a two-step process: mark followed by sweep. Mark will identify if all of them are linked together. Which are linked will be given a flag true, and the ones that are not linked, which are already having the value false as when they were created, those will be swept by the algorithm during the sweep phase. This is the concept of garbage collection algorithm, and I hope you liked this video. If you did like it, do hit the like button, subscribe to CodeWithAni if you haven't already, and I will see you guys in the next video with another important concept in Java. Bye bye guys.